wrapped CryptoPunks project. We launched it in early September, and we gained some space in several spots like CoinList and whatever. So we move about 3 million euros in transaction, bringing CryptoPunks from a price floor of 0.8 ethers to almost 6 ether. Of course, I'm a board member of Commercio Consortium, which is the no-profit organization that is trying to bootstrap the Commercio network blockchain mainnet. My company is made of experienced professionals coming from industry sector, finance sector, and apart from Roberto Ceresia, which is the co-founder with me in black, which who comes from the traditional art fair network. So our mission is to mix the centralized technology with the regulation framework. And that's why we are talking today about self-sovereign identity, with a particular attention to EIDAS framework. I don't know if you know that type of framework, but it's very important to understand what's happening now in Europe. Honestly, it's happening since 2016, and we are building a single market for trust services. Coming to EIDAS. EIDAS stands for Electronic Identification, Authentication, and Trust Services. In Italy, we have a long history regarding trust services. We had the first technical regulation and law in 1999, so more than 20 years ago. At the time, there was no hope to have a digital transformation process that could work on a cross-border base. So a document digitally signed in Italy will have a full legal value in Italy, but not outside of the country. Nowadays, if your solution for digital signature, or in generally speaking, electronic signature, complies with EIDAS regulation, there is one single way to evaluate the full legal value of your electronic document all across the continent. If you see, Italy has a big number of what we can call trust service provider. Trust service provider are classified in two types. One is the simple trust service provider. Another type is the qualified trust service provider. Qualified trust service provider is an organization that has been audited by a third authorized party from the country body that is, let's say, issuing all the regulation for EIDAS implementation in that specific country. For instance, in Italy, we have a body which is called AGID, that stands for Agency for Information Technology in the Public Administration Sector. A qualified trust service provider is able to issue qualified electronic signature, and you can have three types of signature: the qualified one, the advanced electronic signature, and the simple electronic signature. All the three signatures are valid in a law enforcement process, but the qualified electronic signature, which has the highest value, is let's say valid by default in a law enforcement process. So a party has the duty to demonstrate the non-validity of this signature, so it's valid by default. The advanced electronic signature, which is very important for business process, is valid typically in agreement, so contractualization for subscribing to services between parties. to digital identity, we had a long story also in that field in Italy, and we have two ways to officially identify citizen and company, so physical and juridical persons. One is the electronic identity card, which is a plastic card with a chip, which includes some authentication certificates. And the other way to authenticate citizen is called SPID, S-P-I-D, which stands for Public System for Authentication of Citizen and Companies. This SPID framework is based on SAML, Security Assertion Markup Language, but we will see later on. You see that there are a list of accredited and authorized identity provider. You can see Aruba, Namerial, InfoCert. By the way, before founding this startups, I've been working 4 years for InfoCert SPA, which is, as of today, the biggest qualified trust service provider in Europe. And if we look at the evolution of digital identity or online identity, starting, of course, from centralized design pattern, we are now in an age that we can call federated identity model. And the 3 most used standards for federated identity are called SAML, which is the oldest one. The latest version of this framework and specification is from 2008, about 2008. Then we have Open Authorization version 2. And then we have the latest version of OpenID Connect, which has been standardized in 2014, and which is built on top of Open Authorization 2. Introducing the same security element that we already have in SAML. For instance, digital signature applied to the tokens, and introducing also new standards like JSON Web Signature, JSON Web Encryption, and of course, JSON Web Token. But there is an issue with this type of identity model. And the issue is privacy. In a federated identity model, the third party, which is usually called identity provider, is the subject that holds and controls on your behalf your identity attributes. It's the same stuff that happens when you log in with Google, log in with Facebook, log in with Twitter. You are using those services like as an identity provider to subscribe with a token instead of creating a basic authentication credential to a third-party services. Self-sovereign identity, it's an evolution of this design pattern that eliminates the need of a third party acting as identity provider. So the negotiation and exchange of identity information happens directly between the identity attribute holder and the service, without the need of using a third party to interfere in the process. There are a lot of other properties of self-sovereign identity approach, and we will dig down later on. So what is self-sovereign identity? Simply, it's a digital movement which had its birth around 2015, mainly due to Christopher Allen. The digital movement recognizes an individual should own and control their identity. So it's completely devoted to getting back your data, to preserve your privacy. So individuals should own and control their identity without the intervening administrative authorities, and SSI allow people to interact in the digital world as they interact in the natural world. So if I present myself to Alessio, I don't need anyone to, allow this transaction to happen. Okay, maybe I can ask anyone, a third party, to, let's say, confirm my identity or confirm that I have some properties, but that's another stuff. This is called web of trust. So when your identity attribute, which is in your control, are confirmed by other parties, that corroborates them. There are a number of properties of self-sovereign identity. They are called self-sovereign identity principles. You can find them in this blog of Christopher Allen. I guess that you already know Christopher Allen. So highlighted in red, those principles that typically have an implication with a blockchain or a distributed ledger technology. So let's say a registry. Persistence and transparency, the terms are explaining themselves, are related to the fact that your identity should be persistent and permanent, like your physical identity. And transparency involves the registry to be the way to map your identity to a set of keys, a public keys, of course, that you can use to demonstrate the control of your identity. There are some other important properties. Control is the central one, of course, because identity attributes are fully in your control through the use of a specific standard, which is called verifiable credentials. Consent and minimization are other important principles. So when you, let's say, perform a passwordless authentication to a website and you decide to, let's say, share a part of your data, you can decide which data to disclose. And possibly you can also use predicates to demonstrate a property of your identity without disclosing the source data. For instance, being with an age, being an adult without disclosing your birth date or something like that. Another important property is interoperability. So we cannot approach to self-sovereign identity using a silos approaches. And I think that you're in Cosmos and Tendermint, you're already familiar with the concept, since your vision is the internet of blockchain. I totally share your vision and totally agree with that. It's the same stuff with digital identity. You cannot have an identity systems that helps users to protect their privacy without interoperability. And so you need standards. So the main concept of self-sovereign identity is the centralized identifier. What is a decentralized identifier? It's just an identifier made by three fragments. A URL scheme identifier, which of course is DID. A did method identifier. As you may know, we were the first project in Italy to register a did method, which of course we called COM, like Commercio network. So below you can see an example of an account that you can create in Commercio network. And COM stands for the did method identifier. And then you have a did method specific identifier, which of course is the Cosmos address in the hierarchical determinist wallet. It's important to specify that a user may have several DID and may have several DID in different spaces and domain. So as a user, I could have several wallets including in its wallet several different identifiers and with different schema and methods. But without what is called DID document, you can do not so much with the ID. So the DID document is an essential part of a system that we could call decentralized public key infrastructure. I don't know if you are familiar with the old traditional centralized PKI systems, like, I don't know, Prime Key or other certification authority server. Typically there you have the X509 digital certificate that is binding your identity with a public key and a private key. In this case, the DID document is a strange object that allows you to manage in one single JSON file that can be, of course, signed through a JSON web signature to provide the integrity of the file. You can manage several different keys with several different use. There is a de facto standard in cryptography that each key must have a specific use, and you shouldn't use one key for more than one specific use. So in Italy, for instance, in the enterprise market, and it's commonly and widely used to provide citizens with at least two key pair, which may be RSA or elliptical key pair. One is for subscription, and with subscription I mean signing of documents like contracts or whatever. And the other way, the other key pair is used to authentication or encryption. Authentication that may be SSL or TLS authentication or encryption of message. So in this case, you see that we have three different keys. And if we do a parallel comparison with the traditional classic PKI and the distributed PKI implemented by a self-serving identity system, we can see that we can be more efficient with the distributed PKI like that. We don't have to manage three separate objects, but just one. What is the role of the registry? The registry has an important role because if we want to have a decentralized public infrastructure, we have to have a register which is persistent, it's transparent, immutable, that allow a verifier to resolve the decentralized identifier in its decentralized identifier document in order to confirm that the user that is presenting itself through a password-led authentication subscribed to a services is controlling the right public key. Of course, signing message with some private keys. So mainly the registry, blockchain or DLT or whatever, has this specific role. It's not so important and core components of self-sovereign identity. You can have self-sovereign identity also without a registry, but that could be problematic for some aspects. We have been talking about a DID method. What is a DID method? Since we are very early in the stage of creating standards for self-sovereign identity, there are two main organizations that are working on that. The W3C consortium, of course, and the DIF, which stands for Decentralized Identifier Foundation organization. We, as Commercio, we decide to comply to W3C set of standards, which is a DID specification document and a verifiable credential data model. The DID specification model addresses also what is a DID method and what the specification should contain. So if we go to the page of W3C, sorry. we'll see that there are plenty of different methods. Okay, you can find here all the provisional list of different DID method. And you can see that we have also the commercial network one. So if you look at the method, I've been the committer almost 1 year ago. Let's see what it includes. So this commercial network DID method has been approved by the W3C, and it specifies how the DID is formed. We decided to, let's say, produce account already with this prefix in order to have a decentralized identifier as an address. And we will understand later why. This is the schema and an example of our DID document. So we provide two different keys. One is for verification and one is for signature. Then we specify how the typical management operation are carried out. I'm talking about creation of the ID and the DID record in the Commercio full node module that take care of identity. Read and verify, which stands for resolve. Update, that means key rotation. You must be able to renew or, let's say, revoke your public key in case of threats. And the activation, which actually is not supported. And then we're talking about privacy consideration and security consideration. So we then specify identity attributes in the form of verifiable credential. We will see verifiable credential in a few seconds. So since Commercio network is a blockchain devoted to exchanging of documents in a digital transformation flavor between companies, we provide identity credential to person and company. And so we define a schema for this type of elements. You see, this is the exact index of our specification. So, talking about privacy and security, since Commercio network is a public blockchain, every transaction between users is permanently stored in the blockchain. That could be a problem because the sender address and the recipient address are in the form of GID. And you don't want to let a third party know which are your relations. So we implemented the possibility to have a pairwise GID. What is a pairwise GID? It's like in the old days when PGP was born, pretty good privacy, you could have a different key for any of your peer. And that's exactly the same story. So we are using the hierarchical deterministic wallet, specifying a different derivation path in order to keep a different account, so the ID, to talk with a specific peer. So your, let's say, account list is like a telephone agenda, and you will use a different ID to talk with a different person. That's important to prevent correlation of transaction between user and specifically between companies, because Commercio network, one of the main and core services are the electronic delivery transaction. There is a transaction in a module which is called shared document that allows a company to register in the blockchain the fact that it has shared a specific content with another peer. And that could be a commercial or trade document. What is a verifiable credential? Verifiable credential is basically a signed set of claims. You can see a claims if you think about your identity document like passport. Your name is a claim, your last name is a claim, your birthday is a claim. Verifiable credential, so the passport is a set of claim, a signed set of claim in your control. It is signed using a Merkle tree, where each one of these claims is signed with the same issuer keys. You can self-issue, like a digital certificate, a verifiable credential to yourself. But from the business point of view, that wouldn't be very valuable. If a third party that is accountable and liable for that specific assertion, for instance, certify that you have a certain study career and you achieved some results in your university, or you are a member of a certain organization, or you have gained some position, whatever. You have the role of an issuer that is signed this data and provide this data to you. You will be the holder of this data. You will be the one who decide in which form, fully or partially, this data shall be shared with third parties that are acting as a verifier. So if we look at the trust model of self-sovereign identity, now you can see all the pieces that are fitting together. The holder is the holder of a wallet, an identity wallet, which control a set of keys in the form of Decentralized Identifier document, which are permanently stored in a registry. This allows the holder to technically demonstrate its identity, performing something like a FIDO authentication, or generally speaking, a passwordless authentication towards a verifier. But the verifier must know not only that the holder controls some set of keys, but also some identity attributes that are relevant from the verifier perspective to provide some business service. So it needs identity credential. But who issue a credential? The issuer. Of course, in a self-issuing scenario, the holder is the same subject as the issuer. But in business scenario, typically the issuer is a third party. The holder aggregate and store this credential in its identity wallet and present this credential, possibly combined together in something that is called credential presentation. It is a mix of signed attributes in a specific forms that is compatible with what the verifier is requesting to present itself. All the three subjects may use the registry to verify the public keys that technically allow every one of them to verify that the holder is controlling the right keys. Talking about claim types, this is a very early work. It's from 2009 and has been the first works tackling the classification of attributes. So you can have static attributes that are typically used nowadays to, as your identity placeholder. For instance, a national identifier, employee numbers of your telephone number. Well, telephone number is not so static. Let's say social security number, whatever, typically are used as identity placeholder or username. And this is very dangerous because it's an information that you probably won't change for all your life. And as long as you are spreading this information all around, the attack surface of your identity is growing more and more. So the centralized identifier have been designed to protect also this type of information. This is not a technical information. It's an identity attribute that should be managed carefully. There are also credentials related to relationship, of course. So being part, for instance, open source project on GitHub, whatever. There are derived verifiable credentials that come in the forms of credential presentation. And this is the example I was doing before regarding the age. There are capability verifiable credentials. So the ability to demonstrate that you can access some type of resource or can perform some type of operation in a system. And there, of course, to grant interoperability, you have also technology-related, location-related, and generally speaking, context-related credential. This may seem, let's say, a collateral aspect of identity, but it's not. I've been lucky to see the IT security panorama for the last 20 years. And as soon as the blockchain movements gain traction, I had the chance to testify different, let's say, two different generations working on the same stuff. Let's call it, generally speaking, cryptography. If you have to provide a solution for qualified electronic signature, you must comply with this very long series of standards, technology standards. Typically in Europe, the technology standards in the field are provided by ETSI, European Standards Technology Institute, Technology Standard Institute. For instance, you must comply with a certification which is called Common Criteria EAL 4+, for your security creation SSCD. So that's called for signature creation device. In other words, the smart cards or the HSM. Imagine that you could share in your transaction not only the transaction payload, so the signed message, but also a proof that that signature has been performed on a certified device. This is mandatory in the nowadays enterprise market, but it's very, very far away in the blockchain panorama, as far as I know, at least. So we already talked about credential presentation. Credential presentation is a fundamental data constructs in the credential exchange use case. So when a verifier asks a proof of some information and rely, of course, on an ontology set of schema, and so the client can negotiate the construction of this presentation and present it to the verifier. And this can happen also in the other way, of course, because when you create a connection with a verifier, you are managing also all the consent, the term of services, the privacy, in the form of verifiable credential. And so it's very easy to implement use cases that are typically for the GDPR compliance, like revoking consent and whatever. Sorry, this is probably you don't see it very well. It's not top quality image here, but data authentication is a general definition of a passwordless authentication provided by the centralized PKI system. So your client will receive a challenge from the server, and you will be able to sign that challenge and provide this as a response. And the web server will use the registry to resolve the public key, verifying that you own that decentralized identifier, and will be able to verify the signature that you attach to the challenge. That's maybe the occasion to share also your identity attribute in the form of verifiable credential. We already talked about issuer. This is an important element when talking about business and enterprise market. So what is a trusted third party? For instance, in Europe, there is an object that is called European Trust Service List. It's a very big XML file. It comes also in the form of a PDF that includes all the public keys and all the identity attributes of all the organizations that have been accredited and qualified to provide trust services to the market. So if your identity, and I mean your verifiable credential, are signed by an entity like that, you can very easily provide a way for the verifier to trust the assertion that comes from your verifiable credential. And this is exactly the approach that we decided to put into Commercio network. So we have a government entity which creates and let's say states which are the trust service provider allowed to provide services in the system. This is an internal government, but of course we can support external trusted oracle like the European TSL service list. Each TSP with different role, for instance, KYC and provision of identity credential, or standard electronic signature of documents, or long-term archival, or whatever, will act inside the system, providing services to companies. But what happens when two companies must connect each other in a way that will prevent correlation of their transaction from third parties that are looking to the blockchain? The government, through the help of TSP, will provide this company the way to get and gain a public identity. So the TSP1 is issuing a verifiable credential to Alice, which is a public verifiable credential with a public DID. And the same happens to Bob. Alice and Bob can use their public identity to negotiate an off-chain exchange of new DID that will be a pairwise DID connection, allowing them to use off-chain and on-chain those DID to perform transaction between themselves. So let's have a look to Commercio network transaction. It may be of help now. If we see the identity module, we can see that the transaction here allows you to create an identity. How? Creating identity means associating a DID document to your account, because your account is a DID. And so you will be able to create keys through the use of our SDK, which have, of course, a key helper components in many flavors, elliptic curve, AS, RSA, whatever. And you'll be able also to sign this document in order to keep it in provable. Okay. Once you've done that, you, for instance, can share documents with your counterparty through the use of a transaction which is called share document. So the share document, as you can see, includes the sender and a list of recipients. The transaction includes the metadata that are related to the content in terms of URI, schema to interpret the data, and checksum. So of course the registry doesn't include the content, the original content, which is outside, but the recipient may check the integrity of the content through the checksum that has been included in the message. Also, all this field may be encrypted in a different way for each one of the recipients. So you can have a one-to-many message, including encrypted data and that are encrypted through a symmetric key, and that symmetric key will be encrypted with the recipient specific asymmetric key, so the public one. Last but not least, you can ask a signer to use the hash of the document, the checksum, to provide a raw PKCS1 signature of the content. So for instance, if your document is a big PDF file and this checksum is the hash SHA2 of the document, you can have a raw PKCS1 signature that can be used to provide a standard PDF signature to the document. This is a protocol that we are starting to introduce in Commercio network, allowing different trust service providers to provide signature service, like it happens in other non-blockchain spaces, like, I don't know, Cloud Signature Consortium from Adobe, or DocSign, or I don't know, yes.com, which is another framework that allow clients to get one-time signature from a service provider. Okay, I don't know if you have some questions, or do you want to see the software in action through the use of our testing client, which is called Amadeo. I can show you live what it means to create an identity, but feel free to ask me whatever. Since we have 10 minutes left, if there are some questions, maybe we can take the time to have them.
So I do have a question, and a couple other diagrams in the presentation. The government was at the top. Do you have, like, okay, how does the government get registered as the government? And is the root of trust, or
Jacob, hold the fire. I think yeah, Egidio is yeah. Jacob, repeat the question, please.
Yeah, can you repeat, because I don't hear you very well. Sorry.
Okay. Yeah, absolutely. I can repeat. So in this diagram, the government is at the top, and I'm just wondering: is the government a root of trust that issues other types of trust certificates in this model, or is it a special type of entity? What's the relationship to, say, individuals, for example?
Yeah. Good question. Yeah, you're right. It's a root of trust. Exactly. It's the same entity which issued the genesis of the blockchain and states which are the TSP that are allowed within the framework to provide service provider. Commercio network, it's an enterprise blockchain. So we need that if you want to have business value. We cannot approach the trust model as typically is done in a web of trust, pure web of trust style, where there is no root of trust at all, and you can leverage on a web of trust. No, it's a centralized one. Yeah, definitely. And this is not the only one, of course, because as I mentioned before, I'm sorry, there is no hints in the scheme, but we also rely on external root of trust, and specifically the European one, which is a root of trust shared by all the member states in the continent.
Got it. Okay, that actually explains a ton. Thank you.
Yeah, thank you. Other question?
Yeah, but then does it not defy the principle of the DID? The fact that you own your identity, and I mean a representation of your identity, and then there is no censorship possible. I mean, I know other ways and other framework like the sovereign network, but there is no single point of failure in a federation. It's a bunch of nodes that are called stewards, and they participate in a consensus. So there is no really any censorship possible. But in the design you just show with the governments, it doesn't bring much more than a centralized identity and federated identity.
Well, I wouldn't use the term federated identity, because federated identity has to do with the management of your identity attributes. And that's not the case at all. Once the verifiable credential is issued to the user from the TSP, it's in the hand of the user. There may be the case of credential revocation, but if you look at the sovereign framework, they support credential revocation as well. ARIES framework is one of the main libraries to support issuing of verifiable credential and credential revocation. From the business standpoint, you need the revocation of, let's say, non-permanent, non-static data. You can do nothing without that, and you must rely to the issuer of that attestation to check revocation, like it happens in digital certificate. That's why, from the business standpoint, it's very difficult to rely on a pure web of trust. But I wouldn't say that this is a federated identity. We just, create a set of stewards as well, exactly like Sovereign did. And my past company, InfoCert, is using Sovereign to provide a system which is called Thisme. You can have a look to that. Thisme should be this one. Sorry, it's me. Yes, this is based on Sovereign network, and the InfoCert has been one of the first stewards of Sovereign in Europe, and it has a root of trust that is internal. That's quite, typical. But that doesn't imply that the TSP is managing your attributes. No, the attributes is in your hand, in your wallet.
Yeah, I get that, but the fact that, for example, your name is signed by an issuer makes it valid. I mean, you can have your name validated by an issuer, you can have your date of birth validated by another issuer, and all those things are building your own identity that you keep in your wallet. But
exactly.
Yeah. Okay.
That's exactly what happens in commercial network. TSP are just liable and accountable issuer. That's the only thing. But nothing prevents you to issue credential to another user as a user. Okay.
Yeah, of course.
Simply, you must evaluate carefully what is the trust that you can apply to that information. In the other case, when the information is issued by a trusted party, which is liable for that, you can do other use cases. Okay. I just want to point out that if you are interested in testing our framework here, you can go to our project GitHub. And here you will find a rich repository. In particular, you will find this framework, which is actually a boilerplate, where you can test all the transaction of the chain. It's a Flutter application, and you can use it also on your browser. And you can create an account here. So you can generate a wallet, and then you can use that wallet to create your identity on the testnet system or the DevNet one. Okay, so you see that we have our derivation path 0 DID. And then you can, of course, create edit document. First of all, generating keys. Of course, we are using a local storage here, so it's not for you using production. You can derive a document. And I won't do the transaction because I have no coins in the wallet now, so it will fail. But of course, you can set the document here in the chain. So that's all I wanted to tell you in this 1 hour slot.
That's quite a bit, I would say. So I think we are going to wrap up Egidio. So I don't want to. We don't want to use your time any further than what was planned, and we thank you very much for taking the time today. It was extremely interesting, and I hope the team could use some of this information to further improve designs and even to think a bit about it and come up with some ideas for future implementations and improvements. So
Alessio, thank you so much, and of course you can provide my contact to whoever wants to keep in contact with me about these topics. I'm very happy.
I will. Will do, totally. And would you be happy to share with us the slides?
Yeah, absolutely. I will send you in WhatsApp in a few.
Thanks very much. Okay.
Okay, guys.
Thank you very much.